Oh, okay, welcome back. So we need to finish off example 4. A couple of things I want to draw your attention to here is, first of all, we came up with this equation. Remember, this is Sam's earnings, so he gets $12 per hour. That's his slope. So the slope is 12 over 1. Okay, so that's his rise over his run. Notice that there's no b value. Okay, so, and we'll talk more about that before. And this has a special name that I don't know if I've called it that. This is called its first differences. And you're going to remember that name from grade 11, and you're going to see it again. And that's where you take y2 minus y1. And those are your first differences. Okay? And usually they go up by ones on this side, but we'll talk more about that in a minute. So let's flip over and look what they want me to do. They want me to graph Sam's earnings, and they want me to label the axis. So Sam's earnings, we had a bunch of points for Sam's earnings. They were 0, 0, 1, 12. So these were Sam's earnings. Let's just put it down here. These were the x values. These were the y values. So it was 0, 0, 1, 12, 2, 24, 3, 36, 4, 48, and 5, 60. Hey, kiddo. You joining us again? Okay, just a second. Have a seat for a bit. So Sam's earnings. So we're going to label all the axes. So we need to put something down here. We'll call this money or amount, earnings. We'll come across here. We'll call this number of hours worked. Now notice that I'm doing something here. I'm only creating quadrant 1. Do you know why? Does it make sense to have negative hours worked? Would it make sense to have negative hours worked? No. Would it make sense to have negative pay? No. So the negatives don't make any sense in this case, do they? So only quadrant 1 really matters here. I'm only going to have positive hours worked, and I'm only going to have positive earnings. Now the hours worked go up to 5. 1, 2, 3, 4, 5. We could do that. We could also do 1, 2, 3, 4, 5. That might be a nicer looking graph. Why don't we do that? So we'll make 2 hash marks 1, 2, 3, 4, 5. And we'll make this, we're supposed to go up, I could make that $6, $12, so that could be 12, 24, 36. That might be nice. So each hash mark is $6. So what I'm doing is I'm using up most of the graph, right? This is the earnings in dollars. So if I plot my points, remember what the equation was. The equation that we worked out was 12x. So that means if he worked 0 hours, he gets 0 pay. So that point 0, 0. This point's 1, 12. This point's 2, 24. 3, 36. Do I need all the points to get the line? No. I need enough to make sure that I'm not going to make a mistake. Question, does it make sense to bring the line down here? No, because that would be negative hours, right, and negative pay, so that's not going to make any sense. Does it make sense to put an arrow on the line indicating that it could go up if he worked more hours? Yeah, that makes sense. So there you go. That's Sam's earnings. So if he works 1 hour, he gets $12. If he works 2 hours, he gets 24 hours. If his paycheck is $60, he worked 5 hours. So we can work backwards and forwards from this. Pick any 2 points and calculate the slope. What do you notice about this answer from answer B? Well, we can pick any 2 points. Let's pick this point and this point to calculate the slope. Let's call this point 1. Let's call this point 2. Now, Fernando, you asked a very good question. You said, do I have to use the formula, or can I use the graph? And when should I do which? And my answer to you was, It's up to you and depends what they give you. So if I look at this question, I look at this, I see the rise and the run, I can see directly from the graph. But I have to be careful here, Fernando, because I have to know the scale of the graph. This is 1, 2, 3. So this distance represents 2 units. Does that make sense? Even though there's a lot more hash marks there, that only represents 2 units. And this goes from $36 to $12. So this represents $48, or 48 units in this case, even though there's only 1, 2, 3, 4 hash marks. So if we use the graph, we need to be very, very careful that we know the scale of the graph, right? So using the graph, it's called the rate triangle method. You're going to say m equals rise over run. So the rise here is 28, and the run here is 12. Oh, sorry, I think I've made a mistake here. This isn't 48. This goes up to 36. This goes up to 12. This is 24. My mistake. I'm so sorry. That's 24 units. That goes up to 36. That is 12. So the difference between these two is 24 units. Just the same way as this is at 1. This goes up to 3. The difference is 2 units. So we're looking at the distance between this and the distance between this and this. Okay, 24 is here. Get a little bit darker pencil. 24, 2. All right, so the rise over the run now. So my rise is 24. My run is 2. 2 divided by 24, or sorry, 24 divided by 2 is 12 over 1, which is the same answer that we got before when we did the first differences. When we look back and we did the first differences, we noticed that it went up by 1s, and the y's went up by 12s. So what this meant on this side was our first differences was that the change in y over the change in x was 12 over 1. The x's were changing by 1, the y's were changing by 12. Over here, that translates to this nice rate triangle. Now notice something. I didn't have to choose those 2 points. What if I had chosen this point and this point? Okay. Well, if I had chosen those 2 points, I could have gone over 1, 2, which is 1 unit, because it's the difference between 2 and 3. And this is between 24 and 36, so this is 12. So its rise over run between those 2 points would be 12 over 1, which is the same thing that we have here. So it doesn't matter which 2 points I use. This rate triangle will stay, now you ready for the word? Similar. They're similar triangles. So that's how that relates. Now, what if we use the formula? The formula was the change in y over the change in x, so it's y2 minus y1 over x2 minus x1. What did I choose to be P1? P1 I chose to be 1, 12. What did I choose to be P2? I chose 3, 36. So this is going to be, looking for a different color, this will be x1 and y1 because it's 0.1. Make it a little bit bigger. This will be x2 and y2 because it's 0.2. So y2 is 36. y1 is 12. x2 is 3. x1 is 1. 36 minus 12 is 24. 3 minus 1 is 2. Do you know what that works out to? 12 over 1. Let's get this out of the way. So, Fernando, it's the same thing over and over again. That's what the slope does. It makes it that triangle, which makes the line straight. Isn't that cool? And you need to be able to do all of the different methods. So I'm going to stop the video here. There's some homework down here from your textbook. You can start working on that, and we'll be back with the next lesson in just a few moments.